In this video, we're going to look at how to create a confidence interval to estimate the population mean when we know the population standard deviation. And I'll do that using Statistics Kingdom first, and then we'll look at MegaStat. Okay, so this is a problem from the homework section of our textbook in Chapter 8, number 95. Among various ethnic groups, the standard deviation of heights is known to be approximately 3 inches. We wish to construct a 95% confidence interval for the mean height of male Swedes. 48 male Swedes are surveyed. The sample mean is 71 inches. The sample standard deviation is 2.8 inches. So then part A is basically just asking, did you read all of this correctly? X bar is our sample mean, and they told us that that is 71. And then sigma is our population standard deviation. Now, they didn't ever say population standard deviation, but they said sample standard deviation is 2.8. So this guy up here, where they said standard deviation, that would be our population, so 3. And then N is the number of Swedes, so 48 would be N. In words, define the random variables x and x bar. So x would be the height of a randomly selected male Swede. X bar would be the sample mean of a sample of 48 randomly selected male Swedes, or the sample mean height, I guess. Which distribution should you use for this problem? Explain your choice. So it would be the normal distribution, since we know our population standard deviation. Okay, so construct a 95% confidence interval for the population mean height of male Swedes. And so we'll just do the state the confidence interval, but we'll see that Statistics Kingdom will show us the graph and all that fun stuff. Okay, so if you go to the homepage, statskingdom.com, you can scroll down until you see confidence interval and confidence interval calculators, and mean is what we're estimating. And we are given just like the descriptive statistics, not the raw data, so we leave that as is. And so our x bar, our sample mean, where am I? There I am, is 71. And the sample size was 48. Do you know the population standard deviation? Yes, we do. So normal is what we want, and 3. And we were supposed to do a 95% confidence level. So I think I still have to type it in. And I'll just leave it as 4 decimal places. Calculate. So there we go. So here's our confidence interval. Up here, it's rounded to 2 decimal places. And here's our margin of error. So 71 would be in the middle, and subtract 0.8487, add 0.8487 to get those 2 numbers, the lower and upper limit of our confidence interval. And then here's a graph showing that. So this is the normal distribution, the standard normal curve. And if we scroll down, we can see our critical value here. So 1.96 is always the critical value when you're doing a 95% confidence level with a normal distribution. So I keep going to the wrong tab. So the confidence interval again was that 70.1513 to 71.8487, and the margin of error was 0.8487. Okay, so let's see how we would do this with MegaStat. I'm going to delete this tab. So you just open up Excel. and go to the Data tab and open MegaStat. And I just did a confidence interval, so it's already kind of highlighted. And make sure mean is selected. And we've already got 95%. And then our sample mean was 71. And the standard deviation, since we're doing, we can kind of play around with it, but since we're doing the z-test or the normal distribution, we want to put in the population standard deviation, I think. So let's just see. And then it was 48. And again, z-test. So preview, I think that's what we got, right? Ooh, where's, there we go. 8515. Yes, so this is coming out the same. And so I can click OK. And so when you're doing that normal distribution to estimate the mean with a confidence interval, you never need to use the sample standard deviation. So we don't need to put it in. I could have thought of that, I guess, when I was dithering about it. So there we go. And if we need more decimal places than 3, we can look at up here when we select that particular cell, and we can see our margin of error and our critical value. So this was finding a confidence interval for a population mean when we know the population standard deviation.